All right, this is our video recording presentation for our vehicle tracking system. We are Team Monroe. Our company name is Red Light Solutions. First, we had to identify some problem boundaries. We have a 14-week goal, divide and conquer approach. We decided to split the project up into 4 components and then communicate interchangeably as needed in order to accomplish the goal. And for our requirement analysis, we knew our program would have to define in a sense of what a car is in terms of the parameters that it entails, and it would have to do all those functionalities. For the requirements list part 2, we knew we had to identify what we needed the program to accomplish in terms of the management of those of the cars and what users can do with them in regards to being able to search for a car in inventory, being able to add or remove a car from an inventory, being able to process orders and manage the sales list and things like that. In terms of system design, we did a prototyping model type of style where we identified our requirements. We kind of did a quick design, built a prototype, and then we looked at it, and then we kind of just redid that process until we got to a point where we could implement and maintain that. In terms of program design, we decided to code the project in C++. We knew we would need a class to represent what defines a car in terms of all those parameters you saw before, as well as what we can do with cars. We also need a struct to hold the details of a sale entry, and which contains a car object as well as some other parameters. We knew we would need some data structures to effectively store and categorize the instantiations of our class and struct. So we have a vector of car objects for the in-stock inventory. We have a vector of car objects for the cars that are in backorder. We have a vector of sale entry objects for units of the sale history. Program design continued. We knew we would need the functionality of printing out lists of the various components. We would need to be able to add vehicles to the various lists. We knew we would need to be able to search for a vehicle. And then we would need a main function that would kind of facilitate the organization of these given functionalities. So let's go through those functionalities. First, let's look through the print function. Essentially, the console will ask the user if they want to print in-stock inventory, backorder, or the sales history. The user chooses, and then it prints out the corresponding information. Then the console will ask the user if they want to go again. They say yes or no. If they say yes, it recursively goes back into the print function. Else, it goes back to main. Okay, in the add vehicle function, this one's prettier because I did it first and had lots of motivation. The console will ask if we want to add a vehicle to the in-stock inventory or the back order. User chooses, we set a corresponding flag. The user enters all the information they would like to, and they can enter just like the color and the model if they like to. They can enter as much as they want. We give them the option to enter 0 for a parameter, and then it just stores NA for that specific part. Then we create a car object based off the information. If the flag's 1, we add that car object to the in-stock inventory. If it's 0, then we add it to the back order. Then we ask the user if they like to add another car. If they say yes, we recursively go back into the add vehicle function. If they say no, we go back to main. All right, and then we have our search function where the console asks where we want to search, in stock or back order, and this will be used for later. That's why there's a flag. The user enters the search conditions, which the cool part about this is they can enter as much or as little as they would like in regard to the parameters in which they wish to search the car for. Basically, you could enter every single parameter, be super specific, or you could enter just say blue Corolla and then just start looking through all the blue Corollas that are in stock or in back order. If the car is not found, we ask if they want to search again. If so, we recursively go through search. If not, we go back to main. If the car is found, we check if it's the flag is 1 or 0, which tells us if it's in stock or back order. We do this because there are different things you can do with the car object dependent on where it's at, because you wouldn't want to be able to sell a car that's on back order. So essentially, if the car is in stock, we can let the user process a sale for the car, which we would they would then enter the cost, the delivery date, or when it's scheduled to deliver, the name, all this information, and then we would create a sale entry struct object and store that in the sales entry list, and do all that stuff and then like erase it from this in inventory in stock vector. We can just transfer the car out, just get rid of it, or we can just view it. Now we can view it also in back order, but the other things that we can do in back order that we can't do in this is if it's in back order, it means we don't have it. So we can have the user process the dealership receiving the car, therefore removing it from back order and adding it to the in-stock data structure, which signifies that they physically have the car, and then it lets them just remove it from the system as well. After that, we give the user the option. Also, you see the arrows going over to search again. If yes, we just recursively go back through search. If no, we go back to main. Okay, this is the main function. It looks the most hectic. It's probably because I drew this last, so all motivation was gone. Okay, so the console basically just asks if the user would like to add a vehicle, search a vehicle, print data, or exit. And so you see the 1, the 2, the 3. It just does the function call for those specific functionalities, and 0 is exit. And then after it completes one of those functionalities, will ask, hey, do you want to go through again? Yes or no. If yes, it just goes back through to the beginning. So with that, the main function is just a big while loop. So we just kind of keep going through that menu and those given functionalities. If they say no, it just exits the program. So for coding unit testing, like I said before, it was coded in C++. In order to really test it, we decided that we wanted to make a function that would randomly generate car objects and sales entries. So we have these giant two-dimensional vector structures that kind of have a bunch of different car models, colors, like different options for all these various parameters. So there's thousands of combinations with all that in sales entries. So we just create a bunch because it's very tedious and slow to manually enter a bunch of cars. And so if we just have the computer make a bunch for us, then we can see what like a real live like version of the program would look like in action, and how we could print the list and just see the whole thing in action, essentially. This gives us a level playing field in order to explore all these flows of control and ensure there's no issues, and we can thoroughly test each given component. With integration testing, there's different strategies we can utilize. We decided to go with the bottom-up integration strategy. So we just started from the bottom, like honestly, with the Hello World program, just to kind of get back into that C++ mindset, and then just started like building up until we got to the point where we thought we were done. And then that's with the prototyping type of style, where we would go back and look at what our needs and if it was complete or not, and go back, edit it, add on to it, all that type of stuff. But just totally from the bottom up. System testing is the last main thing we have to do. This just involves the last stuff we do before we ship it to the customers. We had to develop a testbed environment, test all these individual functionalities like adding a vehicle, searching for a vehicle, printing the list of vehicles, making sure the program terminates with 0 input, which it totally does, and then all that type of stuff, volume testing by having the random function generate like 1,000 cars, all kinds of stuff to make sure that all of it works in tune with what we designed it to do and in accordance with the project description. So the system will run within a web browser on any devices. So you got training, you got the operator, the user, developers, the maintenance team, car dealers, and the customers. So in regards to training, you have the operator and the user, where the operator are people in the back end, maintenance, the ones programming this design and all that type of stuff, whereas the user are the ones using it, like the car dealership or maybe even the customers themselves, stuff like that. And with maintenance, you have things like fixing bugs, flaws, defects in the software, figuring out how to have adaptive maintenance, perfective maintenance, and preventative maintenance, just to make sure that all the various corners are covered in regards to how the maintenance scales as the design gets implemented in a more like wide way. And then we just have all of our various documentation, which we mostly have the system documentation and all that type of good stuff.